You can spend an entire career learning about security. It's a fascinating, complex field, whether it's computer and software security or security applied to just about any aspect of everyday life. But there are a few overarching, critical security concepts that you should internalize and keep in mind when you develop applications. And by far and away, the most important one is never, ever, ever, ever trust any data that users input. Now, this isn't the be-all and end-all of security in any form, but it is one of the fundamental principles that if you closely and carefully adhere to it, you'll avoid the majority of security problems with your applications, particularly web applications. This security concept has a lot of implications. Any user input data that you display on a page should be HTML encoded or HTML attribute encoded if it's displayed as an attribute value. Don't even try to sanitize user input data yourself, such as using a whitelist or some other homegrown method. Even the experts have a hard time getting this right. So don't even try. And I'll actually talk a little bit more about that shortly. And use HTTP-only cookies when you won't need access to the cookies using a script, which is almost always the case. And don't get caught in the trap of thinking that user input data is only the data entered into form fields on a page. Think about query string parameters, AJAX requests, post data, hidden form fields, anything and everything the user can muck around with. And yes, this includes things like post data, since users can use Fiddler and other HTML header manipulation tools just like you can. Okay, so that's the most important one. Second up, which is actually a corollary to that one, is that you don't want to ever give users an opportunity to tamper with data. For example, let's say that you have a form on a page that you use to gather information from the user. For convenience, you have a hidden form field that contains the user's customer ID. Hidden fields are easily viewed using page source, but a customer ID isn't any kind of sensitive information, is it? So why would you care about that? Well, the customer ID itself may not be any kind of a big problem, the actual value. So somebody knowing that their customer ID 10 or 10 million in 10 or whatever is probably not the most important sensitive data that you're dealing with. And in fact, there's a decent chance in some systems that the user already knows his or her ID number. But by placing the ID in a form sent to the browser, you're open to tampering so that a malicious user could change the ID value, submit the form, and potentially receive back sensitive information about another customer. This would be a serious breach of privacy and security. And in fact, I remember my early days of poking at websites to find issues like this. A major engineering professional group had just this kind of vulnerability, and I very unintentionally learned way too much about one of my former members. I reported the problem, and the problem got fixed right away. Thank heavens. So the idea is that you just want to prevent data tampering problems by not sending this kind of information to the browser in the first place. Instead, save it to a session variable or use some other mechanism to save the information without sending it to the user, such as retrieving it from a membership provider. But if you absolutely must send it to the browser, at least encrypt it using very strong encryption. Okay, then another related item is a whitelist is always better than a blacklist. Now, I said a short while ago, don't even try to sanitize data using whitelists, blacklists, and whatever, but if you have to do it, if you have to try to do it, a whitelist is always better than a blacklist. Because what a whitelist does is it defines what's allowed in the user input instead of what isn't. Clever attackers will always come up with clever ways of getting around disallowed things. That's what makes hacking so much fun. If literal strings of SQL keywords is in a blacklist, an attacker will figure out a way to encode them somehow. You can just count on that. So instead, define only what's allowed, that you're absolutely sure is safe. I guarantee that you'll start out every time thinking that the input that this particular form field needs is just too random to make a whitelist work. Well, my advice to you is try harder. Okay, now to be fair, there are some edge scenarios where you'll have to make do with a blacklist. It's better than nothing. But understand that you're leaving a significant security hole in your application, begging to be exploited. And that's when you'll need to rely on the next critical security concept, which is defense in depth. Defense in depth harkens back to medieval castles. I'm sure you've seen pictures of old castles scattered around Europe and other areas that consists of this huge stone monolith, huge building, thick stone walls, sometimes as much as 10, 15, 20 feet thick at its base. It's surrounded by a moat. It has inner chambers, inner core sections, where if an attacker wants to attack a castle, first of all, they had to cross the moat full of deadly crocodiles. And then they had to batter through the 5-foot-thick door or the 20-foot-thick stone wall. And then they had another stone wall and another gate to get through. And it was layer upon layer upon layer of security. And so that's the concept of defense in depth. If you're talking about data within a database, you want to make sure that sensitive data is encrypted as a last-ditch defensive measure. Within that, you want to make sure that the SQL Server or other database engine is highly secured. Very granular permissions. It's very difficult to get at data that you don't have access to. And then the SQL Server instance is hardened. And the server machine is hardened. The network is hardened. So it's layer upon layer upon layer of defensive measures that is really the only way of protecting resources that deserve protection. So it's defense in depth. All right, then the next security concept is least privilege. And here's how Wikipedia defines and describes least privilege. Quote, in information security, computer science, and other fields, the principle of least privilege, also known as the principle of minimal privilege or just least privilege, requires that in a particular abstraction layer of the computing environment, every module, such as a process, a user, or a program, on the basis of the layer that we're considering, must be able to access only such information and resources that are necessary to its legitimate purpose. Okay, end quote. So what that's essentially saying is that any user or application should have the absolute fewest number of permissions or the least privilege in order to get their job done. No more. Because the idea is that when an attacker gets control of the application, not if, but when, what is that attacker going to be able to do by getting control of that application? If it's just a very small subset of things, maybe select permissions on a single table within a database, and that's all that application has permission to do relative to the database, then that attacker is going to be able to read the data from that database, which probably isn't good, but at least they can't update it, change it, delete the table, delete the database, shut down the server. Okay? So the absolute least privilege. Okay, so those are the critical security concepts that you'll hear me talking about over and over again as we talk about the security features of ASP.NET MVC, particularly when I start talking about the threats that you need to design your applications to withstand. So make sure that you understand these concepts. They're very, very important. And there's certainly others, but these I think are the most important for the purpose of our discussion here. Now I want to talk a little bit about ASP.NET Web Forms versus MVC in regards to security. Because web forms have a lot of built-in security features. So the server controls automatically, in most cases, HTML encode displayed values and attributes. And this is a great way to prevent, or at least make harder, cross-site scripting attacks, one of many kinds of attacks against web applications. It also has security features on view state. It can be encrypted and validated. And this helps to prevent tampering with posted form data. There's also request validation. This automatically raises the alarm if there's embedded HTML or script within user input data. And then there's also event validation that helps prevent injection attacks and posting of invalid values. Now, specifically about MVC is that it can make use of the same features, but often you have to handle the details yourself. Comes automatically built into ASP.NET Web Forms, but you have to do it yourself within MVC. For the most part, this is a good thing. But you do have to be way more careful and vigilant as you build your application. Because this is really one area where there's a stark difference between Web Forms and MVC. Over the years since the first release of ASP.NET, the framework has gotten a lot of security features that just work out of the box in order to protect your applications, users, and other resources. You usually have some control of these features, but it normally takes extra effort to get around them. But it really boils down to having complete control with MVC, while ceding control with Web Forms for the benefit of getting the automatic features. So I suspect that kind of control with MVC is why you're considering using it, because you really do have a lot more control than in ASP.NET. Okay, and one of the big ways is that MVC gives you far more control over the HTML emitted by your application, which means that you have a lot more responsibility. You do get some built-in protection, such as HTML encoding by default in Razor, but not in Web Forms, not in the Web Forms view engine. And you also get request validation. But it's also way easier to leave security vulnerabilities in your application. And it's always the case of when attackers find them, not if. I want to mention a great resource for any kind of web developers. It's just an amazing resource with lots of tools that you can make use of, a lot of information. And don't be fooled by the ASP in the name. It applies to all web technologies across the board. So the OASP stands for the Open Web Application Security Project. So I just can't say it enough. I highly recommend it for web developers across all technologies. And the URL is www.owasp.org. Go. You don't have to be a member. It's great if you want to be a member and support the organization, but that you'll find that there's a lot of really good stuff. It is organized in, I'm not sure the absolute best way, but they didn't ask my opinion, and you can find the information, but it takes a little bit of getting used to navigate the website. But once you're familiar with it, there's a lot of good stuff there. And in particular, I want to talk about its top 10 list of web security threats. This is something that they update every couple of years. They're actually a little bit behind in updating it. The last released version, as I speak, was 2010. They have put out some proposed revisions, but they're in the discussion stage at this point. But it's quite possible that there's a new version. It is something that they do about every 2 to 4 years. And what's really nice is that Troy Hunt, he's a fellow developer security MVP of mine, he produced some information that adapts the top 10 list to ASP.NET specifically. Less so specifically MVC, but a lot of the stuff, most of the stuff, applies to MVC applications as well. And you can get to his site using www.troyhunt.com. So he has extensive blog posts. He turned blog posts about the top 10 into a free ebook. You don't even have to register to download the book, and even an online course. It's just some very amazing stuff. Highly recommend it. Okay, so what's the top 10 list? I'm just going to run down things briefly, but this is from the 2010 edition, which is the current edition as I speak. Okay, so the first on the top 10 list is injection. So they talk about this as injection flaws like SQL, OS, and LDAP injection occur when untrusted data is sent to an interpreter as part of a command or query. The attacker's hostile data can trick the interpreter into executing unintended commands or accessing unauthorized data. And in that description, untrusted is a critical term, because untrusted data comes from any source, either direct or indirect, where integrity is not verifiable and intent may be malicious. This includes manual user input, such as form data, implicit user input, such as request headers, and constructed user input, such as query string variables. Consider the application to be a black box and any data entering it to be untrusted. End quote. So once again, that's getting back to never, ever trusting user input, anything that the user can get access to, including post data and various other things that you need special tools within the browser to get access to. Okay, so keep in mind this is the top 10 list of vulnerabilities of security flaws found in web applications today. Cross-site scripting. This occurs whenever an application takes untrusted data and sends it to a web browser without proper validation and escaping. And this kind of attack lets attackers execute scripts in the victim's browser, which can hijack user sessions, deface websites, and redirect the user to malicious sites. Okay, so fortunately, cross-site scripting is something that we've had to grapple with, and there's a lot of features within MVC that help prevent that. So there's some good news with this particular attack. Another problem is broken authentication and session management. So this is the situation where these features are often not implemented correctly, and that allows attackers to compromise passwords, keys, session tokens, or exploit other implementation flaws in order to assume other users' identities. And then there's insecure direct object references. This happens when a developer exposes a reference to an internal implementation object, like a file, directory, or database key. Without an access control check or other protection, attackers can manipulate these references to access unauthorized data. Then a personal favorite, one that I cover in this course, is cross-site request forgery. And that's often pronounced CSRF. And sometimes the acronym is written with XSRF. So OWASP's description of this is that a CSRF attack forces a logged-on victim's browser to send a forged HTTP request, including the victim's session cookie and any other automatically included authentication information, to a vulnerable web application. This allows the attacker to force the victim's browser to generate requests the vulnerable application thinks are legitimate requests from the victim. This is just a very, very insidious kind of attack. Cross-site scripting probably happens more often. It's more often a flaw, but a CSRF is more problematic in that it can do a lot more damage. And I'll talk more about that. All right, another big problem is security misconfiguration. OWASP again. Good security requires having a secure configuration defined and deployed for the application frameworks, application server, web server, database server, and platform. All these settings should be defined, implemented, and maintained, as many are not shipped with secure defaults. This includes keeping all software up to date, including all code libraries used by the application. This is definitely a severe problem with security of web applications. But I suspect it's also one that Microsoft likes to tout because this is motivation for people keeping their software up to date, including Windows and the other technologies that are used by their web application. Another biggie is insecure cryptographic storage. Many web applications don't properly protect sensitive data, such as credit cards, social security numbers, and authentication credentials, with appropriate encryption or hashing. Attackers may steal or modify such weakly protected data to conduct identity theft, credit card fraud, or other crimes. And then there's failure to restrict URL access. In this case, many web applications check URL access rights before rendering protected links and buttons. However, applications need to perform similar access control checks every time these pages are accessed, or attackers will be able to forge URLs to access these hidden pages anyway. Another favorite is insufficient transport layer protection. In this case, applications frequently fail to authenticate, encrypt, and protect the confidentiality and integrity of sensitive network traffic. When they do, they sometimes support weak algorithms, use expired or invalid certificates, or don't use them correctly. So a big one here is the failure to implement SSL on a site. But there's a lot of other factors that are involved. And the final one on the list is unvalidated redirects and forwards. Web applications frequently redirect and forward users to other pages and websites and use untrusted data to determine the destination pages. Without proper validation, attackers can redirect victims to phishing or malware sites, or use forwards to access unauthorized pages. Okay, so those are the 10 on the list with some of the descriptions from OWASP. They have lots more detail about these attacks. And Troy Hunt then, as I mentioned, has adapted a lot of the information to ASP.NET. So if you go to the website, search for the top 10 for 2010, there's a lot of links with plenty of information about these attacks. On the OWASP site, it's general web information. Sometimes they have specific web technologies as they apply to the top 10 list. But you can also go to Troy Hunt's site. And again, please consider joining OWASP. It's a very worthwhile project to support. It's voluntary. All the information is pretty much free, but it's a nice project to support.